Hello friends, welcome to the session. Friends, once again I'm coming with problems on remainders. Though I have taken too many sessions on this remainders number system, still some students are getting doubts. So one of the students has sent so many problems on remainders. So I'm taking them in this session. I'm taking the problems in this session. And though I have already discussed the basics, how to find remainder, simple cases I have already discussed in my number system sessions workshops. So once again, we just go for a quick revision of the basic concepts, how to find the remainders. Okay, now see, we know the expansion, the basic expansion, that is x plus y whole square, x plus y whole cube and all that, right? So suppose I take x plus y whole square. Now x plus y whole square is x square plus 2xy plus y square, right? Now if x plus y whole square is divided by y, then what will be the remainder? What my question is, if x plus y whole square is divided by y, what will be the remainder? That means I have to divide this expression by y and I have to get the remainder, right? Now this expansion of this is this. So if I divide this or this, that will be the same thing. Okay. So the first basic thing you have to understand is, see, remainder in individual cases you have to find out, then you have to add up all of them. Okay, so you have to find out the remainder when x square is divided by y, or 2xy is divided by y, and y square is divided by y. Okay, so I find out the remainder in these three cases. So this, or this. So here 2xy by y. 2xy is multiple of y, so remainder will be 0 in this case. Y square is multiple of y, so remainder is 0 in this case. So we are left with x square only. So x plus y whole square when divided by y, the remainder will be x square. Right. Similarly, x plus y whole square, if it is divided by x, then the same thing, x square is multiple of x, so 0 remainder. 2xy is multiple of x, so 0 remainder. Y square, if it is divided by x, y square we cannot say whether it is multiple of x or not, so remainder will be y square. That means if this expression is divided by x, x plus y whole square divided by x, remainder will be this number, y square. So this funda we will be using to solve the problems on remainders. Okay, similarly I can go for x plus y whole cube also. So that is x cube plus 3x square y plus 3xy square plus y cube. Okay, now if this entire expression has to be divided by x and we have to find out the remainder, then these three terms are multiple of x, only we will be getting the remainder from this term. Okay, that means x plus y whole cube, if it is divided by x, remainder will be y cube. Okay, so that's pretty simple. So this is basically binomial concept. So we will be using binomial theorem. Precisely this is binomial theorem only. If it is x plus y raised to n, okay, so there will be n plus 1 terms in this expansion. Okay, x plus y raised to n, there will be n terms in this expansion, and all the terms will be multiple of x except the last term, that is y raised to n. Okay, all the terms will be multiple of x except the last term, that is y raised to n. The expansion will be x raised to n plus nc1 x raised to n minus 1 y, right? At the last, the term we are left with x raised to 0 and y raised to n. Okay, so this is the term that is left, that is not multiple of x. Okay, this I have shown over here. The same thing in a like big way you can say. Okay, so I hope this thing is clear. So in generally, if we talk about competitive exams these days, the problems on remainders are frequently asked, whether we talk about CAT or maybe XAT or CMAT, or even uh, the exams like SSC CGL. These days, the questions from remainders, precisely number system, are, I can say, frequently asked. Okay, so if your basic concepts are clear, you can do the problems on remainder easily. Okay, none of the problem takes more than a minute to solve. Now, simple problems can be solved using binomial theorem or this concept, but some of the problems are really um, of higher level. So over there we need to use some of the theorems, some of the concepts. You might have heard about Euler's theorem, you might have heard about Wilson's theorem, Fermat-Little theorem. So all these theorems are used, or concepts are used to find out the remainder in some cases. Okay, so we will be discussing even problems based on them also. I have some 18-20 questions to solve on all these concepts. So I'll be using almost all the concepts, maybe binomial, maybe Euler's theorem, Fermat's theorem. Okay, and good number of examples will be taking of each concept. So by the end of all these problems, all these questions, I hope you will be confident on number system, problems on remainders. Okay, now we take the very first question. Now here the very first question is 13 raised to 239 divided by 16, what will be the remainder? Like see friends, in simple question like suppose 2 raised to maybe 52 divided by 3, what will be the remainder? So these sort of questions you can solve very easily, because 2 and 3, what is the difference? That's just 1. So 2 can be written as 3 minus 1 raised to 52. Right, so as I described earlier, 3 minus 1 raised to 52, if it is divided by 3, what will be the remainder? That is minus 1 raised to 52, or I just can say 1. Okay, so these are like very simple questions. Even if it is 4 raised to 52 divided by 3, then I can write 3 plus 1 raised to 52. So the remainder will be 1 raised to 52. That's ultimately 1. Right? Over here it becomes bit difficult, right? Bit difficult, more difficult than these sort of problems, but not that difficult. You can solve them easily. The only thing is you need to think a bit. Right now, what exactly you have to think, you just listen to me carefully. You will definitely get a number uh, or a clue from here. Right, the very first thing, just simplify it. Just one step simplification, find out the difference of 13 and 16. Right, 13 can be written as 16 minus 3 raised to 239. Right, so in the very first, see, you don't have to write this. Okay, because in exams you have to save time also, so avoid writing too many steps. The first thing is you don't have to write this. Now 13 is what? Minus 3 from 16. So in the first step, what will be your remainder? That is minus 3 raised to 239. Okay, so that is the first step that you have to write. Now I was talking about a clue. So you know, 3 raised to 4, that is 81, and 16 into 5 is 80. Okay, that means 80 is multiple of 16, and 81 we can get from this. Okay, and 80 and 81, the difference is just 1. So we can convert this problem to easier one like this. Okay, but that you have to think how. Now 3 raised to 4 is 81. I just put this minus sign somewhere here. Now 3 raised to 239 cannot be converted into 3 raised to 4. So what we can do is we can find out the multiple of 4 and exclude the remaining part. So the last multiple will be 236. Okay. So what I can do is 81 raised to, or what I can say 3 raised to 4. Okay. So 236 and 3 raised to 3 will be different. So that is 3 raised to 3 I write over here. and the remaining part, so I divide 236 by 4. Okay, so this expression can be converted to this 3 raised to 4 raised to 59 into 3 raised to 3. Okay, minus sign, do not forget this. Now this is what 3 raised to 4 is basically what, 81, and 81 can be written as 80 plus 1, right? So 80 plus 1 raised to 59 into 27. Okay, this expression can be converted to this, but again you don't have to write this step. You should be able to think without writing this step. Okay, so if it is 80 plus 1 raised to 59, your remainder will be 1 raised to 59, that means precisely 1. That means your remainder is 27, that is left out with a minus sign. Okay, now 27, still it is bigger than 16. So further the remainder will be, we can even deduct 16 from 27. So that's 11 with a minus sign. So your remainder is, we started with this big number, now we have got minus 11. Means this expression when divided by 16, the remainder is minus 11. Right? Or what we can say, we can convert this remainder to a positive one, that is 16 minus 11, that is 5. So the ultimate remainder when 13 raised to 239 is divided by 16, that is 5. Okay, so the important thing is to find out the relationship between these two. Okay, that as I explained you over here, right? We see somewhere a number that is just having just giving difference of 1, okay, in the power of 3, and which is multiple of 16. Okay, so I hope this problem is clear. I take the next one. See this one, 39 raised to 22 divided by 7. So once again we have to proceed in the same manner as I did earlier. First of all, just remove the number that is multiple of 7. So I can remove 35, right? So this number can be written as 35 plus 4 raised to 22, right? 35 plus 4 raised to 22. So as I told you earlier, you don't have to write this. So now you are left left with 4 raised to 22. Okay, so now your problems start from 4 raised to 22. Now you can think of a number that is there in the power of 4 and that is closer to multiple of 7. So that you can think a number 63 and 64. 63 is multiple of 7 and 64 is 4 cube. So what I can do, 4 raised to 22 I can write down as 4 raised to 21 into 4. Reason being 4 cube is 64. Okay, so 22 is not multiple of 3, so I cannot convert this into 4 cube. So 4 raised to 21 is precisely 64 raised to 7, and then this is 4. Okay, 21 can be written as 3 into 7. So 4 cube raised to 7. Okay, so 4 cube is 64, 64 raised to 7. Now divide this term by 7. 64 can be written as 63 plus 1 raised to 7. So the remainder will be 1 raised to 7. So precisely that is 1 and this 4. So final remainder is 4. Okay. So you saw how easily the problems based on remainders can be solved. Okay, I take more examples, the next doubt in the series. Now see this, 2 raised to 1003 divided by 25. 25 and 2000, 2 raised to 1003. If you can think of 1024, that will be great, because that's 2 raised to 10 and that is just 1 less than multiple of 25. Okay, so what you can do is 2 raised to, I just can write it 2 raised to 1000 into 2 raised to 3. Okay, so 2 raised to 1000 can be written as 2 raised to 10 raised to 100 into, this is 8. Now 2 raised to 10, that is 1024, right? So 1024 can be written as 1025 minus 1. So remainder will be from, if I divide by 25, the remainder will be minus 1 raised to 100. I just explain it over here if you don't get confused. 1025 minus 1 raised to 100. See, once you get enough practice now, you don't have to write each and every step because that will be really time consuming. Okay, so 1024 can be written as 1025 minus 1. Now this is multiple of 25, so the remainder will be just minus 1 raised to 100. So minus 1 raised to even number, the remainder is 1 only from this step, and 1 into 8, the final remainder is 8. Okay, so this way you can just speed up your process. If you don't write anything, then you will be able to speed up. And if you write so many things, your time will be really. Uh, it's. I hope you are able to understand what I'm trying to say. Okay, now try the next one. Now this is bit advanced level problem. A bit advanced but not that difficult. Once one or two problem will make you comfortable. See, this is 4 is to 96 divided by 6, and you have to find out the remainder. Now 4 and 6, both of them contain 2, a number that is 2. Okay, 4 is to 96 is also multiple of 2, and 6 is also multiple of 2. So to make the problem easier, what you can do, you can take 2 as common. Right, so first of all, what I can do is, instead of 4 raised to 96, I just write it 2 raised to 96 2 times. Okay, because if 4 is 2, then 96 will be double to make the number same. Okay, so that's 192. Okay, now it has to be divided by 6. Now just follow certain steps. 2 raised to 191 into 2, and this is 3 into 2. 6 is 3 into 2. Okay, because 6 is 3 into 2, I broke this number 2 raised to 192 as 2 raised to 191 into 2. In fact, this is precisely 2 raised to 191 into 2, that is nothing but 2 raised to 192. Right, now I can take these 2 as common. I am not cancelling this. Please be careful, you cannot cancel this because your answer will be really wrong. Okay, so don't cancel them, just take them as common and find out the remainder in this case. Now further, 2 raised to 191, 2 can be written as 3 minus 1, and this is 191. So if you divide this entire expression by 3, the remainder will be minus 1 raised to 191. So that is precisely minus 1. Okay, now this 2 you had taken common. So now multiply this minus 1 with this 2. Okay, because remainder is not minus 1 but it is minus 1 into 2, so that's minus 2. So remainder, if it is negative, then you can deduct this number from 6. So 6 minus 2, that is 4. So your final remainder is 4. When 4 is to 96 is divided by 6, your remainder is 4. Okay, so the important thing that you have to keep in your mind over here, whenever you take this number as common, you can take this, not a problem, to make the problem easier. So but when you take this number common, multiply whatever remainder you are getting from this step, multiply this number with that particular remainder. Okay, I have already explained this concept in my algebra sessions or basic number system session. Over there you can refer it once again. So I hope you are clear. Let's take the next one. 5 raised to 116 divided by 63. Okay, once again, can you think of a number that is there in the power of 5 and that is closer to multiple of 63? Yes, we can think of 125 and 126. 63 into 2 is 126 and 5 cube is 125. Okay, so what I'll do, I'll convert this number to 5 cube. So for to convert this number to 5 cube, this power should be multiple of 3. Okay, so 5 3 into okay, so 3 into 38, that is 114, that is multiple of 3, and we are left with 2 more. So you can write down this number like this. Okay, now this is what, 125 raised to 38. Okay, so 125 can be written as 126 minus 1. So 126 minus 1 raised to 38 when divided by 63. Shall I write it? Just, I think now no need to write. If it is divided by 63, the remainder will be minus 1 raised to 38 because this is already a multiple of 63. So minus 1 raised to 38, that means just 1. Okay, now this one into this 5 square, so that is 25. So final remainder when 5 raised to 116 is divided by 63, the remainder is 25. Okay, so that becomes very simple. If you can think of this set of number, the problem becomes very easy. Okay, now we see a different problem over here. 5 raised to 99 divided by 66. Um, Now what is the difference over here? Say so far we have done the problems on remainders when we were easily getting the relationship between these two. Okay, but over here it's a bit different, right? 5 and 66, the relationship is not that direct. So what we have to do, we have to find out a direct relationship. Now the very first step is, see this number 66 over here, it is not a prime number, but we can break it up, right? So first of all, you need to make factors of 66 which are co-prime to each other. Not necessarily to be prime, but the factors should be co-prime to each other, right? So the factors of 66 are 11 and 6. Here 6 is not prime, 11 is prime, but 6 and 11, they are co-prime to each other. Okay, so the very first step is just factorize this number into co-prime factors. Okay, so that's 11 and 6. Now 5 raised to 99 divided by 11, what is the remainder? And 5 raised to 99 divided by 6, what is the remainder? So you have to find out the remainder in each case. Okay, now from 5 to 6, the relationship is very easy because 5 can be written as 6 minus 1 raised to 99. 5 raised to 99 can be written as 6 minus 1 raised to 99. So remainder will be minus 1 raised to 99. So I can say minus 1, right? So 5 raised to 99 can be written as multiple of 6 minus 1, because if 5 raised to 99 is divided by 6, the remainder is minus 1. Okay, so that means it is in 6x minus 1 format. So 6x minus 1, that means if you divide 6x minus 1 by 6, you will be getting minus 1 as the remainder, right? So 5 raised to 99 is in 6x minus 1 format. Okay, similarly we have to find out the relationship between 5 raised to 99 and 11. Now you can reduce the number, like 5 raised to 99, I can write down it as 125 raised to 33. Okay, 125 raised to 33. So that's 5 cube and 99 I divided by 3. See, each and every step you don't have to write, just for your reference, for your practice only I'm writing down them over here, otherwise no need to write. Now when 125 is divided by 11, the remainder will be 4, right? Precisely in this case it will be 4 raised to 33, or I can say 2 raised to 66. Okay, 4 raised to 33, 2 raised to 66. Now when we come to 2, now the problem becomes easy because in 2's power there is a number that is 32, which is closer, which is having just difference of 1 from 11's multiple. Okay, so 2 raised to 66, I can write down 2 raised to 65 into 2, which is 32 raised to, 2 raised to 5 is 32. So it's 65 divided by 5, 13. Okay, so this is converted to this. Okay, now 32 raised to 13, when 32 is divided, 32 can be written as 33 minus 1. So 33 minus 1 raised to 13, I write for you, no need to write though. So 33 minus 1 raised to 13, when it is divided by 11, the remainder will be minus 1. Minus 1 raised to 13, that is minus 1. And this minus 1 into this 2, the final remainder is minus 2. That means this number is in 11y minus 2 format. Okay, do not take x once again, because x, the value of x and y may be different. Okay, obviously they will be different. So this number 5 raised to 99 is in 6x minus 1 format and 11y minus 2 format. Now by hit and trial you have to put up the values of y, and you have to get put up the values of x and y, and you have to find at which point you get the same value, and that value will be your answer. Okay, so since 11 is this is bigger number, obviously it will be below 66. So since this is bigger number, I just put up the values of y over here and get 3 4 values. So The very first one, y, if I put y as 1, so I'll be getting 9. 11 twos are 22, so 20. Okay. Now, out of this, which one of them is in 6x minus 1 format? So, 53 is in 6x minus 1 format because 6 nines are 54. Okay, other numbers are not there in 6x minus 1 format. So 53 is the correct answer because that is in 6x minus 1 format and 11y minus 2 format. So when 5 raised to 99 is divided by 66, your remainder will be 53. Okay, when I'm explaining it to you, it is taking huge time because for the first time you are doing these sort of problems probably. Uh, but once you practice with these sort of questions, you'll be able to do these sort of problems in just maybe 1 or maybe 1.5 minutes, not more than that. So break the number into its factors which are co-prime to each other and find the remainder in individual cases and then find out the common values like this. Okay, so I hope this is clear to you. Let's go to the next. Similarly, we try this question. 55 raised to 190 divided by 153. Now 153, 5, 6, 7, 8 and 1, 9. So it's multiple of 9. So precisely it is 9 into 17. Okay, 17 and 9, they are co-prime to each other. So we'll find out the remainder in each case with 9 and with 17 both as well. So 55 raised to 190 divided by 9, the remainder will be 1 because 54 is multiple of 9. Okay, so remainder will be precisely 1 raised to 190, that is 1 only. So this number can be written as 9x plus 1 format. Similarly 17, the very first is 17 into 3 is 51. So we are left with 4 raised to 190. Okay, so that is actually 51 plus 4 raised to 190. So it is 4 raised to 190. Now 4 raised to 190 can be written as 16 raised to 95, right? 4 square I did, so half of 190. So that's 16 raised to 95. Now 16 and 17, they are closer to each other. So 16 can be written as 17 minus 1 and that's 95. So if this is divided by 17, the remainder will be minus 1 raised to 95. So that is precisely minus 1. Okay, so this number is in 17y minus 1 format. Now quickly write down the table of 17 and deduct minus 1. This is 9x plus 1 format. Okay, 8, 9 and 10. Divisibility rule of 9 is sum of digits should be divisible by 9. Here it is 9 plus 1, that is 10. So this number is 9x plus 1 format. Okay. So this number is in 17y minus 1 format as well as 9x plus 1 format. So when 55 raised to 190 is, if it is divided by 153, the remainder will be 118. Okay. I hope it's clear to you. We move to the next.